Hello and welcome to my Unreal Engine tutorial for beginner. As we know, the Unreal Game Engine, also known as UE4, can be very complex, and developing your own game can be also very challenging, especially if you are a beginner. For that reason, I decided to create an easy beginner tutorial that will cover the most important features of Epic's Unreal Game Engine. The content of this Unreal Engine beginner tutorial is easy to follow, and it will allow you to get started fast. And most important, it will help you to get quick results. The same principles can be also applied to the new upcoming Unreal Engine 5, or also known as UE5. My name is Bernhard. I'm a professional game developer, CGI supervisor, 3D artist, pipeline technical director, director of photography, and CGI lighting artist. Camera work and look development have been always my favorite things to do. And I have been in the 3D world since over 2 decades, working in the film industry, game industry, tech and design industry, automotive and aviation industry, and I have been working also on feature films, TV shows, commercials, teasers, trailers, video games, animations, VFX, virtual production, product visualization, architecture visualization, virtual reality, and virtual experiences. Wow, that's a freaking long list.
See if you can keep up.
Over the last 10 years, I have been using the Unreal Game Engine for daily production, and especially for cinematography, camera work, layout, pre-visualization, lighting, and look development. In this Unreal Engine tutorial, I'm going to teach you how to build a very simple game. By the end of this tutorial, you'll have learned 7 basic things. Number 1, how to create a new UE4 or UE5 project file, including all the project settings, including how to move around in 3D space, and how to use the Unreal Engine interface. You will also learn how to set up ray tracing when using your NVIDIA RTX card. Number 2, how to create basic shapes, forms, and geometry, and especially how to import 3D geometry from other software packages like Blender, 3ds Max, Maya, Cinema 4D, Rhino, SketchUp, Revit, or using third-party plugins like Datasmith, Quixel, or importing 3D models from platforms like Sketchfab using the GLTF importer. Number 3, how to create materials. Basic materials, understanding PBR shaders and PBR materials to achieve photoreal looking render results. You will also learn how to use super quick and fast Quixel materials as well as substance materials. Number 4, basic lighting. Understanding what lights can be used, setting up lights, how to use the sun and sky system, how to set up a high dynamic range based image lighting, also known as HDRI lighting or IBL lighting inside of your game engine. I will also teach you the basic understanding of light values and their importance, and I'm also going to cover all different light types. Number 5, camera. My favorite part, of course, is camera work, understanding and learning the basics of a physical based camera, no matter if you would like to become a director of photography or if you love cinematography. Camera work is very important, and in this tutorial you're also going to learn the basics of a physical based camera and how to use them in your shot and in your project in a very, very cool way. Number 6, the sequencer. How to use the Unreal Engine sequencer with all the powerful options and features. This is also a quick and very powerful introduction how you can combine it, especially with camera sequences, animation work, character animation, visual effects, blueprints, and any other 3D assets. Number 7, rendering. Of course, you would like to render still images or even animation. By the end of this tutorial, you will also learn how to render your animation sequence, how to use the proper settings, formats, and how to edit your master sequence. At the end of this Unreal Engine beginner tutorial, you will be able to create a similar scene file you can see here. Of course, you can also download my Unreal Engine project file for free from my website, fedibull.com. If you have any questions, please feel free to leave them in the comments below the video. I will respond to all your questions as good and fast as possible. Also, if you haven't done so, please check out my YouTube channel, in which you'll find a lot of other helpful Unreal Engine tutorials. So let's get started. First comes first, let's go to the website unrealengine.com, create a profile and download the latest Unreal Engine version. Once this is done and you installed it, you open it with the so-called Epic's Game Launcher. And when you click on it, you will see exactly how the user interface looks like. This is current. It might look a little bit different on your end or in future. But as you can see on the very left tab, you can pick here the Unreal Engine. If you select that, then you get those different tabs here. We have the Unreal Engine where you can see featured content, news, very cool stuff. You can always see what's going on and what's new. You have also a learning section, which basically also gives you the opportunity to download different demos, examples, and project files. Very good to know as well. You have the marketplace. The marketplace is a very cool place because you can actually search for assets you would like to use. You can use also free assets. And, like for example here, a very good example. This is free. You add it to the cart. Then you go to your cart. You click on checkout, basically like a shopping cart. And it works very, very quick and fast. You can place the order. There is $0 because it's free. And later on, you can create this project. We don't want to do this right now. I just wanted to show you. And then you have also those assets and you can migrate projects like this. But the most important part is actually the library. And when you look in the library and you installed your version, you should see now your latest version. What is important is set it as current, whatever version you would like to use. Whenever you have any troubles with the Unreal Engine and you would like to have a new installation, or you want to have it verified because maybe you are running into errors or crashes, this is how you do it. You click on verify and the original files will be overridden. What you can see here also is the projects I basically have on my hard drive here and I created. And you have underneath the projects the so-called vault. And in the vault you have, as you can see, all kinds of different projects and assets you either purchased from the marketplace or you got for free. So as you can see, my library got really, really big. But I also show you then later on how to use this and what it's good for. Now, you can launch the game engine either here through the launcher, but you can also launch it up here on the top. This is really up to you. So once you launch it, you can see that the Unreal Editor basically pops up. It's a fresh launch. And you also can see here I have even Steam VR installed. We don't need this because I also do VR development. But what you can see then is this is how it starts. So you select or create a new project. And in this particular case, I want to show you how to start a project from scratch and, like completely blank. So I click on games. Let's do this. Click next. And then, as you can see here, you have different presets and different options. But I recommend really start something from scratch with the blank, complete blank project file, so you don't have any other different project settings. It's very, very important. So you click next. And then here from the project settings, if you work, of course, also for desktop and console, which we are doing here right now, you want to keep everything as it is, maximum quality, blueprint, desktop, console. You don't need to install any starter content at this point. And I want to enable retracing. This is very cool then later on when I show you, of course, lighting features and options. And in your project folder here, I recommend select a folder where you have enough space on your hard drive and then call it whatever. And I call it beginner tutorial. So when you do this, you click create project and it's launching a new project completely from scratch. So once the editor is up, we have the project called beginner tutorial, and on the upper left you see it's untitled because it's an untitled level. So but before we keep going doing anything else, I think the most important part is immediately click on the top icon here. It's called project and editor settings. Click on it and you have underneath project settings and plugins. When I start a project, I first check on all my plugins, and as you can see, there are all plugins. There are, in this particular case, 349 plugins detected, and you can also see there are 346 built in. Now the plugins I'm going to use is, for example, the HDRI plugin. So if this is unchecked, just click it and make sure it's checked. And whenever you do then changes, you will see that the Unreal Engine editor must be restarted. So I'm going to use the HDRI backdrop. Also what I use, just click in built-in, and then you have here the search tab and type in sun. And also, as you can see, sun position calculator. This is a plugin I'm going to use. Another plugin I'm going to use is substance. So you also type in substance. And now when you see under the built-in, it's not visible. It's because you need to go under all and then make sure that substance is also basically enabled. I'm jumping back here to the marketplace of the Epic Game Launcher. In case if you wonder how to get plugins, you can also find some of them, like for instance the Substance plugin in the marketplace. And you can clearly see here, I already own it. It's basically free and you can install it very simple. You click then here on install to engine and you select then the particular engine you would like to have it installed. In my case, it's already pre-installed and we have it already. This is why you can see it when I'm jumping back here to the Unreal editor and go under plugins, and under all I type in Substance. You can see it here already, it's installed. So this is the first thing I'm going to do. You might also wonder about the Megascans plugin. This is a plugin that can be installed to link to the Megascan library and to the so-called bridge application. And how to install the Megascan bridge plugin, I created another very in-depth tutorial that would be a little bit too long here. I recommend watching it, but you don't need this plugin right away. But during the course, I will show you why it's super cool to use it. So another important plugin I'm going to use all the time is Datasmith. In order to activate it, go under Settings, Plugins, and then it's a built-in plugin, so you don't need to get it from the marketplace or whatever. Just type in Datasmith and then make sure that let's make sure that all the Datasmith plugins are activated. You can see it here. It's already supported for Cinema 4D. So from Maxon, we have the Datasmith CAD importer, Datasmith content, FBX importer, GLTF importer, IFC importer, the Datasmith importer itself, as well as the Datasmith runtime. So let's make sure that all this is activated, and I will show you how cool that plugin actually is, and I'm using it constantly on a daily basis. Once the Datasmith plugin is activated, you will see it right here, right next to the settings icon. So the next thing I would like to show is, again, click on the settings, project settings. First of all, what you can see here on the left, you can see that you can always click into sections. You have crypto, description, gameplay, maps, modes, movies, packaging, supported platforms, and so on. So there's a lot going on. You have, of course, those big categories like project, game, engine, editor, platforms, plugins, and so on. But the most important settings I show you for now is actually on the very top. When you click on it, you see here the search bar. And whatever you search for and whatever keyword you search in the tab, in the search details tab here, you can find then inside of all the project settings. So for example, if I would like to search for ray tracing, all you have to do is type in ray or ray T, ray tracing, and you can see, ray tracing was enabled. It's true. Keep in mind again, if you are changing project settings, some specific project settings like ray tracing, there is a restart required. But we want to keep ray tracing on. So this is the first thing you want to check. Another thing is clipping. I usually change the default settings from 10. Usually it's set up at 10 to 1. So if the camera gets closer to an object, if the camera gets closer to a 3D object, you're still able to see the edges very clearly and it's not clipping it. So what else are we going to change in the project settings? There is one more major part I would like to show you in the project settings, and this is in the physics game engine. And I changed the simulation from project default, or simple and complex, to use complex collision as simple. And the reason why I'm going to do this is because when you add a feature pack like a third-person character, you can run around and all the geometry you have inside is as a simple collision shape, so to speak, defined, and you can start right away. So that's a very, very cool option. Now let's get started on the most important things. First of all, you want to start a new level. So we are working in this beginner tutorial project, but every project can have multiple levels. So you click on File and Create New Level. And then you can see there are also templates or presets, levels you could use. I recommend we start completely from scratch and you select Empty Level. And if you do so, you can see only the grid because in your scene file is nothing. First things you can create, you can select from the left Actors tab, Basic Shapes and Geometries. The first thing you can do is under the Basic tab, you click on a plane, click on it, left mouse button, drag and drop it to the viewport. So the keyboard shortcuts, W is for moving objects, E is for rotating objects, and R is for scaling. So when you would like to scale the plane, for example, just like in one direction, you select. So you can see X has the color red, Y has the color green, and Z has the color blue. On the right side, you see the so-called world outliner, and that shows you how many objects, actors or assets, whatever you want to name it, you have in your world, in your 3D world. As you can see right now, we only have the plane. You can select it, F2, you can press it to rename it and call it floor or whatever. So underneath this plane or the object we just created or the actor, we have also the details panel. And in the details panel, you see all the other parameters from that plane. You can see here the location, and you can also drag and drop the position here on the X coordinate. You also have here the Y coordinate or like Z coordinate, so up and down. You can do the same, of course, in the rotation, as you can see. So you can set back everything also to 0, 0, 0. Then you have it in the location of 0, 0, 0. And the scale, you can also enter here the numbers, or you can just simply select the X or the Y coordinates or axis. So the next thing is, now let's add another few basic shapes. For instance, here a cube, and you can also use here drag and drop a sphere, and you can also scale it, of course, and make the sphere larger, etc. Now, as you can see, under the lit option or here under the perspective option, you have also the options to show it unlit or to see a wireframe mode. And when you click the wireframe mode, you can see, what we just dragged and dropped to the viewport. How to navigate. The typical navigation keys are W, A, S, D. While you hold down the right mouse button and you click the W key or the S, D, you move forward or backwards. And if you click the A button, you go to the left, and D is for the right. So WASD are the typical gamer keys for navigation. Alright, so next thing, we want to save this level because until now we didn't even save this level. So to do that, go under File and then click on Save Current As, and then you can specify a name and you can just call it, like I do here, level 001. Now where you would like to save the levels, this is totally up to you in terms of your personal organization. So you can of course create under content another folder and call it levels, and then inside of the levels folder you can save it called level 001. Now underneath your place actors tab you can see the content browser and the sequencer tab. Now the content browser will show you all the folders and the hierarchy inside of your project. Now if you would close this level or this project, you will not see this as your default level. You need to go into your settings, project settings, and then within here on maps and modes, you can specify your default map. As you can see, as it is right now, the default map is set to template by default. But if you want to load your level, which we call level 001, just select this as your editor startup map. You can also, of course, change this here to the game default map. So once this is done and you close it and then you open it, next time you're going to open the Unreal editor, it will automatically load your level. So the next important step is geometry import. So before you import any geometry, I want you to add a light so that we can actually leave the brush wireframe mode and we can also go into the lit mode. So go on the left and click on lights, and then keep in mind the HDRI backdrop is enabled as I showed you before. So if you haven't been doing so, on the settings and plugins built in, type in HDRI. And let's make sure that HDRI is activated. So once you have this activated, you see the HDRI here on the left. It's called HDRI backdrop. Just click on it, left mouse button, and drag and drop it onto your canvas or into the viewport. When you see this flickering, it's nothing else than the HDRI backdrop is coplanar with the plane we created. So if you move this in the Z direction here, HDRI backdrop is in the world outliner selected. Go down on the details panel and just move it a little bit below, as you can see, or above. And as soon as the backdrop isn't coplanar with the plane we created before, right, it's not flickering anymore. So you can do, of course, the same by selecting the floor and then move it a little bit underneath the grid or whatever, or above. But now it's all about geometry. First of all, we brought a light in it, so this is not really complicated, and we can actually see now our base geometry. When you go back here to basics, of course you can add other base primitive objects, like here a cone. You can bring in cylinders, whatever you like. It's totally up to you, right? So you can see that geometry, base shapes and forms can be moved around either way with the pivots. You can, as I told you before, with the W button, you can move them forward, backward, left and right. You can also snip, so to speak, those functions. And it's kind of cool when you want to rotate, for instance, the cube, and you click E for rotation, and you have a 10-degree angle activated. Then you can also see in the viewport the number, and that's pretty cool because then you can rotate those objects very, very accurate, right? So of course another thing is in terms of scaling, as I told you before, W, E and R are the keys you can actually jump in between. Scaling options, very easy. Just select the pivot you would like to change, X, Y or Z, and you can make those adjustments. When you make those adjustments, you can also see in the transform node, right, in the transform attributes, that it's going to change. And of course you could also type in the numbers here and make here some proper adjustments as well. And when you run the game, it's important to understand the static, stationary, or movable geometry. So static objects, it can't be changed in the game. You know, it allows baked lighting, it's the fastest rendering, and as it is in reality, if you would have a static object like a house or whatever, a fixed geometry you don't want to move, then this is the way to do it. A stationary object can be changed in the game, but not moved, and it enables also cached lighting methods. So of course I'm not covering here any more details, but it's important that you do understand those three different options. And movable means it's totally dynamic, it's for movable objects, and I'm going to show you here right now a quick demo what it actually means if you are playing a game. And we are jumping immediately into this. Of course, it's all about geometry, but also about a game. And most of the time people ask me, so Bernhard, how can I run now a quick game? How can I create a game? We created already an environment, and we have here a few primitive objects. So if you go up here, you can see the play button, and if you click play, it automatically simulates for you already the gameplay. And you can move around with the WASD keys, of course, and with your mouse, and this would be like a game. But for most of you guys, that doesn't seem like, hey, that's not a real video game, or that's not in runtime, because usually I see a player, first-person shooter game, or is it a third-person game character mode. We created our first environment, and let's add a game character. To do so, to the actual geometry, you see here, you click on the content browser to add import, and then on the very, very top, you have the option to add a feature content pack. So click on it. And when you do so, you see you have a first-person shooter, you have flying modes, you have puzzle, rolling, and so on. What I show you here, for instance, is adding the so-called third-person character. So all you do is select it, click Add to the project, and Unreal does it all for you. For all in the sudden, this feature package is basically added to your project. You want to save everything, so File, Save All. Now, when you click Play, you will still not see this in action while the game is actually activated. The reason why is in the project settings, you need to make sure that the third-person character is actually activated. To do so, click on Settings, go to Project Settings, and then again on the Maps and Modes, on the Project Maps and Modes, you see here by default is the Game Mode Base activated and selected. When you click on it, you see now here the third-person game mode. Select it and click Save. And when you do so, and you click now Play, you see your third-person character is popping up, and your character is basically in the gameplay, and you can run around and you can interact with the geometry. One thing I want to mention again is, don't forget when you added the first primitive geometries and you started the game and launched the game, that in the project settings you have under the collision tab, if you search in the search tab under simple in the engine physics, we set at the beginning of the project settings, if you didn't catch this, right, the simulation to use complex collision as simple. This is very, very important because every game engine works, of course, with physics and collision objects in the background in runtime. And if you don't select use complex collision as simple, your character will fall through this, will not detect this as a collision object, and the gravity will kick in and you will just fall and fall and fall. So this is the first step, how to launch a game in a very quick, short period of time. And as you can see, we added a few primitive objects, and hey, here we go. This is so cool with Unreal because you can really create a game, in a very, very short period of time. So now let's jump into the next stage, the next phase. What if I would like to rotate in the gameplay a geometry? So this is what I introduced you before, that you have static geometry. Everything is static here right now, stationary and movable. So let's say we want to rotate this cylindrical form or shape here, right? And let's further say in the rotation, we want to rotate this object on the y-axis. So what you can do now is under the details panel, you click on add component. And what you do is under the search tab, you can type in move. And then you can see rotating movement is something that means, hey, I want to have a rotating movement. So click on it. And now I want to demonstrate you and show you what is happening and what's going on if you add this. When you click play, and how the components are also important between static, stationary, and movable. Because when you click play, you will get an error message, or basically you can see here the cylinder is not rotating as it should. And the reason is, you see here now the error, and by the way, to stop the gameplay, just click the escape button. You can clearly see the log file, it's great. And the error you receive is, hey, this static mesh has to be movable if you would like to move it with the rotating movement component, right? So as you can see, because it's static, it's not working out. So if you change this now to movable, and you check also here and see, aha, we have a rotation on for 180, but let's do this here to 360 on Y, and we click play. Now we see it's rotating. And look at this, how cool is that? We have in a very, very short period of time a rotating object. And yeah, I would say it's pretty cool, right? So you see, this is also how you can animate objects and how you can get started with your game in a very simplified way. So it's actually fun. All right, so this is about primitive objects and geometry, and of course like simple features where you can animate things and move things around in the gameplay. Now, next step, let's cover the import of geometry into your Unreal game engine. How to do that? Well, there are several ways, and as I showed you also before, we installed the so-called Datasmith plugin. Don't forget under settings and plugins built in to check the Datasmith, which comes already built in, and then activate all the Datasmith importer features. Okay. So let's get started with one of the first importing objects, a free geometry you can use. For example, for this purpose, I go to Sketchfab, and in Sketchfab, you can download free models. For instance, thank you very much, PAK DevTech. He uploaded this wonderful Douglas A4 Skyhawk model. And you can download this model for free and use it, of course, also if you are giving the artist all the credits. So as you can see, when you download, you have several options. You have the so-called OBJ format. Yes, you can use this, and you can also import OBJ formats into the Unreal game engine. But there is even a cooler geometry import. It's called GLTF auto-converted format, which I prefer. There is also augmented reality, which I don't use. So for example, let's download the GLTF format. And when you open the folder, you can see I already did this here before. It's a zip file, and then I extracted the zip file in this folder. And then in here you see the GLTF format, a bin folder, and the texture maps. So everything comes with it automatically. But how do you import this model now into Unreal? Well, very, very simple. Once you activated the Datasmith plugin, you click on Datasmith button, and then you navigate to the 3D model you just downloaded. So in my case, it's on the 3D models downloads. Here's the Douglas A4 Skyhawk. And then I click on Scene GLTF, click on Open, and the Unreal Engine is asking me, hey, where do you want to import that data? What I recommend doing is I click on my content folder and create inside of my content folder a Datasmith folder, and I create a new folder and I call this folder Skyhawk. So now I know I'm going to import the entire geometry into that folder. Now when importing, You are also asked if, hey, if there is an animation, would you like to import it? There is no animation, I don't want that. Any cameras, I don't want that. Any lights, I don't want that. But what I would like to import is, of course, the geometry itself and all the materials and textures. And everything else I leave as it is by default. You just click on import, and then here we go. You have the model in your scene file. Look at that. Of course, you have to consider that when you import the geometry, that you have scaling options and scaling features. Because if you would run here the game, you can see that this model would be a miniature at this point, right? So that wouldn't really work out, but no worries. That works very, very simple and very easy. You can see in the world outliner, there is now your scene from the Skyhawk, okay? You can actually also rename. So you can go in, click on it, F2, and say like, hey, this is my node, my root node, so to speak, from the Skyhawk. And when you do so, everything that is attached to it, hey, are you okay? Everything will be attached to this root node. Are you okay with it? And you say yes. But the cool thing is that you have, of course, scaling options. We learned this before. So when you click the R key on your keyboard, you can increase it, you can lower it, and you can scale it in the way you think this is the right size. So if you click play here, you can see, this looks already pretty sweet. And as you can see, the import with the GLTF is really amazing. I'm not going into materials right now, and I'm not covering any more on the lighting because this is all about the geometry. We will cover this later on. But as you can see, it's amazing how fast and how quick you can get a model from Sketchfab into Unreal because of the wonderful Datasmith GLTF importer. Okay. So when you check now your folder, you can also see under the Skyhawk scenes, there are the materials and the texture map. Okay, so you can also double click on it and check it all out and see, wow, everything is in here and it's very well organized. So this is a fantastic way to start a project and to import a geometry. But what if you are going to use a different software package? What if you're going to use, for example, 3ds Max or SketchUp, or if you are coming as a designer from any other software packages like Blender, Cinema 4D, Maya, and so on. So we will cover this here as well with the next steps. Okay, first of all, if you're going to use any other 3D software package, you need to download the Datasmith exporter. So for example, if you're going to use 3ds Max, SketchUp or Revit, you have, or Rhino, you see it here, you have to download the exporter and then install it. But that's very simple to do. You basically go to the unrealengine.com website, search also for the Datasmith export plugins, download the ones you really need for your software and install it. And once this is done, I'll show you on a live example how you can import, for example, a SketchUp model or like a 3ds Max model. Let's go to the 3D warehouse from SketchUp. As you can see here, so what we have here is a little house, for example, you can download for free. I click on download. I download the SketchUp 2018 model because I have the 2018 SketchUp. And once the object is loaded and you're familiar with SketchUp, you go to File and then Export. And you click on Export 3D Model. And as you can see, this is very, very important. I'm choosing here now my 3D models and downloads folder. I created here a SketchUp folder already. And as you can see, you have to select the type Unreal Datasmith. Okay, so this is very important. Don't export like FBX or whatever. Use the Datasmith plugin. So I do this. The file is called Incord, Gene, and Michael. So thank you very much for sharing this wonderful little house here. And this is it. So once you exported it, you go back to the Unreal Engine. And if you would like to import this Datasmith model again to the Unreal Engine, then you do the same as we did before with the Sketchfab model. So you click on the Datasmith plugin. then you search for the content, downloads SketchUp. Here is the Datasmith file we just exported from SketchUp. I click OK. And then again, inside of the Datasmith folder, I call it SketchUp House. Again, I would like to import geometry. If there are any materials and textures, that's what I would like to import. Everything else I leave by default. So as you can see, the file was immediately assigned to this scene file. But what you will also notice is if you select it, you can see it here now. The root again has the name import from Gene and Michael. And you can see that there is not just a scaling issue, there is also a geometry issue. But I'm also covering that. First of all, we can scale this up as I showed you before. X, Y, and Z, just scale it up. The next thing you would like to check is, of course, also you can see that it looks like we have either way geometry issue. That means that can be a shader problem, or it can also be that the geometry has flipped normals. And I don't want to go into any crazy specifics, but what I recommend doing is by checking the geometry when you bring something in, there is a so-called basic shape material. And this basic shape material, when you go in, you want to make sure that it's also two-sided. That's very, very important, just from the beginning and just as a quick startup. And once you have this checked to two-sided, you can go into all this geometry you can see here in the elements and into the materials and just assign that material. And when you do that, you realize, wait a minute, the geometry imported actually perfect, but because it's not a two-sided geometry with faces, from normals to the inside and to the outside, and this is very typical for SketchUp models, right? Then it's a material problem. And you can fix this by just selecting the basic shape material, select it and make sure that two-sided material is on, click Save, and then assign that to the material slots you can see here below. The cool thing about the Datasmith plugin and the importer is that it's a container. You can see it here. And once you save it, all the data is going to be saved inside of this container, inside of your Unreal Engine game. But the cool thing is, if you are a designer or you're working for a client and you have constant changes, right? And those changes are made outside from Unreal, of course, like for example here in Sketchfab. And let's say you want to change the height, the size of the wall, or you have major other changes. Then all you have to do is once you get this scene file again, or this project file, you export this thing again. And all the updates will be automatically updated if you click on your importer and you say like, okay, re-import and update my container. And then all those different, like changes and edits will be addressed in your Unreal scene file. All right, next free model. Let's try Autodesk 3ds Max. I was going to the website TurboSquid, found this free model. That's a chair. Let's download this chair. Of course, I'm going to pick here either way. You can pick a V-Ray scene file or a Corona scene file. I'm just selecting the V-Ray one. Show in folder. Here's my download. I extract it here into the so-called Charles Club Cherry scene. That's about it. And then I'm opening the scene file in 3ds Max. Open that and load it. So whatever you see here, there will be always like some error warnings or some conversion optimization things. Just click yes and okay. It really doesn't matter for this purpose, because all you want to do is you want to use a free model into the Unreal Engine. You need to install, of course, the Datasmith exporter plugin before, like I showed you. And then you click export, and then you change this here again to Unreal Datasmith. I also go to my folder, which is 3D models, downloads, and then here's my chair, and I just call it chair. It's important that you check the type for Unreal Datasmith, and then I click Save. I say, hey, by default, visible objects include everything, and click OK. And here we go. You will run into some error messages when you have overlapping UVs. That's totally normal. And then you go back into your Unreal Engine, and let's click on Datasmith again. And in the Datasmith container, we have the downloads. We have here the chair. I click on my chair, and then in my folder, I create a new folder. I call it chair. Like we did before, click OK. I import the geometry, the materials, and the textures, and leave everything else as it is, and click import. Now, once this is done, you can see, aha, my chair is actually here. You can see it here. Chair is here. It might be even the right size this time, and you don't have to scale. And you can see we have materials and texture maps. Everything is in here. When you click at it, we have 3 elements, 1, 2, 3. 3 materials have been assigned, and voila, you have also successfully imported geometry from 3ds Max. All right, let's get started with materials. But before we start diving into the materials, I want you to do one more thing. Please, let's add right now a new actor. If you go over to your Place Actors tab, type in Post Process Volume, just drag and drop it to your canvas. So this Post Process Volume has a lot of parameters. You see below the world outliner, once the Post Process Volume is selected, you see the Details panel here. And you see that has a lot of different parameters. First of all, assign this post-process volume. Anything that is within this cube is going to be affected. Now, for our scene file and most of the scene files, I want to make sure that this is infinitive so that it's not bounded within this cube. So what you can do is type in unbound, and then you see here, make an infinite extent and unbound this whole thing. That basically means whatever you assign or whatever options you assign here and values to all the different parameters, it's going to affect it to the entire scene file. So the next thing I want you to do is type in exposure, and that's what we are going to change here. And we want to change the metering mode from auto exposure to manual exposure. So when you do this, your scene file should turn black, and the reason why is because it's underexposed right now. So right underneath the metering mode, turn on the exposure compensation and type in here like 10, give it a value of 10, and then you can see it will brighten it up, and it will, adjust the exposure according to the HDRI value. The HDRI value right now, if you type this in, is set to 1. So that's by standard or in the intensity of the HDRI. By the way, by pressing the G button, you can hide or unhide the actors you have been placing to your canvas. All right, let's get started and let's create your first material. I created here a folder called materials. Then you can create a new material by clicking inside of the content browser the so-called add import button, and you can select here material. But you can do the same by selecting the folder you would like to create this material, right mouse click, and also click material. I give it a name and I call it Bernhard's first material. So you can also see on the lower left there is a little star. That means that material was not saved yet. You can click Save All, and now it's saved into your project file. Double click it and it opens the so-called material editor. Within here, you can specify how that material will behave. What means how will it look like? And I want to show you as a beginner the basics of a so-called PBR material or physical based rendering material or shader. And as you can see, we have a few basic input nodes that will determine how this material will look like. Let's talk about the first node. We can clearly see here it's called base color. How can we change the color? You can see in the palettes on the right side, you have a bunch of different nodes you can choose from. There are also categories. You see expressions and you see functions, and you can show all of it. So, for instance, if you want to change the color, type in constant 3 vector, and that node is a color node. By default, when you drag and drop it to the canvas, it's black. By the way, you don't have to use the palette here. You can also click into your canvas, right mouse button, a search tab is opening, and you can do the same here. I like to do this, and another color node pops up. So right now you have 2 here. You can double click on the first one and give this, for example, a color of your choice. Let's make this, for example, yellow. Now this node has a so-called output node, and you see the base material has different pins or so-called input nodes. You can click on it with your left mouse button and drag and drop it, for example, to the base color. As you do so, you see on the left side a preview of this material, and you can see what you just created. I delete the second color node and I focus now on the next basic input nodes. So the next important node I would like to introduce you is a so-called constant node. By pressing the number 1 on your keyboard and hold it down, and at the same time clicking the left mouse button, you can create this constant node. By default, it has the value 0, and you can see the details parameter or the parameters inside of the details panel by switching between those nodes. You can clearly see if I switch to the constant 3 vector node, I get different details or parameters below my details panel I can control, versus, for example, here my constant node. So by default, the value is actually set to 0. But I would like to show you what it really does. So if you connect that node to, for example, the roughness input node, you can see that roughness determines how reflective this material is, and in better words to describe it, how blurry your reflection actually looks like. So in order to visualize this a little bit better, let's change the color here on the top and let's make this a little darker so you can clearly see on the viewport or on the screen what it does. So you can see roughness is set to 0. That means this is highly sharp reflective. And if you select now this node value, the constant node, and let's say you change this value to 0.5, you can clearly see it's still reflective, but the reflection got very, very blurry. And if you increase this value, it means you increase the blurriness. And if you decrease it and you bring it down to 0, you can also clearly see that it's a very sharp reflection. By doing so, you see that we just created nothing else than a high reflective plastic material. So what else do we know here, and what other parameters do we have to specify? The second one I would like to introduce you is the so-called specularity. So let's do the same. You create another constant, click the number 1 on your keyboard. By holding and pressing it down, also press the left mouse button, and you created a second constant node. And now let's connect the output node to the input node of specular. And when you do so, you can see, wait a minute, now my material changed again in the output, in the look. And this is because the specularity has a strong impact. If the value is set to 0, you can see how blurry it gets again because there is no specularity. It looks almost like it's absolutely matte. So by just adding or changing this value to 1, you get back to the high glossy value of a highly reflective plastic material. So this is how you can control the specularity. For this purpose, I put it back to 1, and let's just keep it right now fully highly reflective. So you can see when you rotate the sphere, depending on the HDRI, what you can see here right now in this preview. This is how you create a very high reflective plastic material. So another very important input node I would like to introduce you is the so-called metallic node. So let's do the same. Push the number 1 keyboard button while holding down the left mouse button. And again, when you drag and drop this value into metallic, you see nothing is changing. It has the same look because by default, the constant value is set to 0. And 0 means it's not metallic at all. It's the opposite. And what's the opposite from metallic is plastic. But if you change this value now to 1, look at this. what you see is, whoa, the behavior of my material is now changing, and it definitely looks much more than metallic. Of course, you can also have it as a mix in between. You see like 0.5, 0.1, and you can change those values depending on how you would like to see your material, right? So that's the metallic value. When you look at those 4 basic input nodes and you understand basics of it, you can create almost any physical based rendered material you would like to create. It doesn't matter if it's fabric, if it's wood, if it's plastic, or if it's metal. So there's of course a little bit more to say so, and I would like to show you the most important nodes you always need to create materials, especially as a beginner. So for example, another very important node I would like to show you as a beginner to learn materials from the beginning is the so-called lerp node. By clicking the keyboard L, hold it down, and then again push the mouse button, the left mouse button, you create a so-called lerp node. And the lerp node helps you to blend 2 different nodes together. And you can see it here. You have an input, it's called A, and you have an input called B. And you have also an alpha node that will allow you to mix between A and B. So the best way to show you what the lerp is actually doing is by creating a wonderful example here. Let's create another constant 3 vector node, and let's connect now the first node into A and the second one to B. I also change the color here and make it very bright yellow again. And in order to show this a little bit better, I don't want to have it metallic. I just keep it plastic for now. And what I do then is I connect the output from the lerp into the base color. And the next thing to see how the blend can be controlled is by showing you 2 or 1 other important node, and it's called Fresnel. So right mouse click, type it in, Fresnel. So a lot of people pronounce the name of Fresnel different. In the US you might say Fresnel. In Europe you might have heard Fresnel or Fresnel. It determines how the fall off curve between 2 different input nodes or color values are determined. By selecting the Fresnel node, search for it, Fresnel, and then select it, you create this node. And as you can see, that node has 3 input nodes and then 1 output node. What I do next is connect the output node to the alpha channel. And then what we have to do in order to control the blend from yellow to black is add another constant into the exponent input node. Do this again, create another constant. In this case, you know already how to do that, and connect it, and by default we have the value 0. Now look what's happening. When you look and really focus just on those 2 nodes we created in the color, and we want to specify here also blend between those 2, you can see that, hey, we have color in the yellow color in the A node, and we have black in the B node. And all we do is we say, look, we have by default now, we control by default now the blend through a Fresnel node with the value 0. Now watch this. If you change the value to 0.5, you can see, whoa, wait a minute. Now I think I understand what it does, because in the center, that's the inner circle, so to speak, the inner side, when you look at the sphere, it is still yellow. But as more as you push the color outside to the edges of the sphere, it gets more black. So if you change this value, let's say to 0.1, you can see it even more dramatically. So more of the black value is spread out stronger to the edges. And let's say you do it with a value of 1, you can see that more yellow in the inside is actually active or visible, and less of the black color in the fall off curve that is crawling to the edges is visible. So that means with the so-called lerp node in combination of a Fresnel node, you can control those colors. And of course you can change now the color in the base to visualize it better and see what it's doing and how it looks. Also, of course, you can now go in and change also the metalness again and say like, look, this is a high glossy plastic material where I can see the fall off from the center to the edges. But again, if I change this to metal, you see how this is affecting overall this shader. Now you can use those basic nodes and the fall off for all the other material slots as well, because a fall off curve, as you can see here, and the blend between two different nodes can be also applied to the specular node and also to the roughness node. It should give you a quick overview how you can create a material by yourself and how you can control the basic parameters. So the next important node I would like to discuss is the so-called emissive color. You find it also here. And a lot of people always ask, especially for beginners, how can I create a so-called self-illuminated material? And self-illumination is nothing else than an emissive color. You can create a color node, and again you create a so-called constant 3 vector node, change this color to, let's say, blue, and then drag and drop this color to your emissive color. And as you can see, and another node I would like to show you is a so-called multiply node. Type in multiply, search for it, and then select it, and then it works the same way. You select the output node from the constant 3 vector, assign it to the multiply node, then create another constant for the B input node because you would like to multiply it with the specific value and connect the output of the multiply to the emissive color. Now at this point your intensity value is, so to speak, set to 0 by default. That means there is no emissive color active. Now let's have a change, and let's change this value to 100. The emissive intensity value of this material is so strong that it really starts glowing. You see this nice bloom effect on the edges as well, and it literally overrides almost all the other parameters because this is the strongest value with 100, right? You can of course change this. Let's reduce it by 10 or by 1, and then you see, aha, this is how this material can be changed, or how it will look like if I'm changing those values. So as you can see, emissive color self-illumination can be applied in a very, very simplified way. Now the next node we didn't discuss yet and I would like to show you is a simple texture map. Alright, let's get started. I created a folder called textures. I click on edit import, go to import to game textures. Then I select just a tile texture map and I double click it so you can actually see it. So this is the details about this texture map, and click file, save all, that it's within your game engine. And now I go back to my material, I double click it and start from scratch. So you have two options to bring a texture map to the canvas. The first thing is you go back to your folder and just select it and drag and drop it to the material canvas. And as you can see, Unreal creates automatically for you a so-called texture sample node. You can do the same, of course, right mouse click and type in into the search, and you could create here another texture sample node. As you can see, you need to exchange then here the texture map you would like to assign, and you can do this very easy by pulling it, also dragging and dropping it into the texture input node of that texture sample node. So I delete the second one because we don't need it. What we learned before, very simple to do. Drag and drop the RGB output node into the input node of the base color. You also notice that we have more things here. We also have then separated channels like you are familiar with Photoshop, the red, the green, and the blue. This is of course combined, the red, the green, and the blue channel, the alpha channel, or the red, green, blue plus the alpha channel. But for this particular case, we just want to connect the RGB channel to our base color. And then what we already learned is, let's make this glossy. So roughness 0, and you can see, whoa, this looks actually like super high, nice polished, floor material. And we can click save, and you can apply it immediately to your game. And if you go back to materials, you can drag and drop this material to the floor we created before. And if you run the game, you'll see that, whoa, that is awesome. We have this super nice sharp reflections, and this looks like a super nice polished tile with the texture map you have been creating. Maybe you don't like the tiling or the scale of your texture map because you feel like, you know what, this is just too large, doesn't really fit. So let's go back to your material and I'll show you with a very simple node you can change the scale or the tiling. And this is called texture coordinate node. You select it, there is only one output, and you bring it to the UVs, to the input node of the UVs, and connect it. And then you can see under the details tab or panel the U tiling and the V tiling. Now let's change this to 5 and 5. And if you do so, you can see the scaling or the tiling gets much smaller. And if you go back here, you see, aha, so the tiling got adjusted and I like it much better right now what I see than what I have seen previously. So this is how you can assign a texture map instead of a color to your base material. Another node I would like to introduce you is the so-called normal map. And the normal map is the one texture map that is used instead of a bump map. It creates the effect that you get some structure inside of your material. It's not inside of the geometry, but you can fake the structure and the depth of a material inside the normal node. So how to apply that? I go back to my textures and I need to import a so-called normal map. A normal map can be created in Photoshop, also very, very simplified. You see those colors here. It's a very typical appearance of a normal map. And then you switch back to your material and you drag and drop it to the canvas. So here's your normal map, and then there is another new node. You will learn right now how to apply also a normal map to your PBR material. And that node is a so-called flatten normal node. So you create it like all the other nodes, and then you connect the RGB output from your normal map to the normal input map of your final material. And as you can see, automatically adds a depth value to it. You can see it here in the preview. You can save it, and once you saved it, you can see what it did to your game material. And of course, if you play it, you can also see, yes, it's definitely here. The next thing is I also want to show you how you can control the strength of the flatness or the intensity of your normal map. What you want to do is you want to create another constant and connect this value with your flatness. By adding the number 1, the normal map is not assigning or applying the effect, because the value of 1 is balancing it out. If you push it back to 0, you see you definitely get this bump or the normal map is affected. Another thing I wanted to show you is what you clearly could see is that we assigned texture coordinates, a different tiling to the texture sample, the base color, and that is not aligned, of course, as you can see, with the tiling of the normal map. Because when you look closer, the tiles here do not match with the normal map. So the good news is that this texture coordinate we created, we cannot just use for our base color. Nope, to keep this very simple and organized, you can see it here. We can use this node also for the UVs on our normal map. And as you can see, now those nodes are aligning. Click Save and then go back to your game. And you can very clearly see how nicely those nodes are now aligned. All right, now let's talk about opacity. That's very, very important. Let's create a new material here. And let's call this material opacity, also known as transparency, or you might also know it called refraction. So first thing first, what we already learned, let's do this here. We add a constant 3 vector nodes and we give our glass material or opacity material a base color. The next thing we want to do is let's give it some, even if it's glass and not metallic, I kind of like it. Let's give it a metallic look or feel of a value of 1, and then in the specular, I give it a value of 1, and I also assign immediately a roughness value, and let's do it very, very high reflective in a clear, sharp reflection. Now, as you can see, if we would go with the simple shader material with those settings, it looks like perfect chrome. But of course, we would like to use opacity. And as you can see in the material, opacity is not active yet. So what we have to do is you go to the blend mode underneath the material section and you change this from opaque to translucent. Once you do that, you see you're losing here the pins metallic, specular, and roughness. So we want to reactivate that, and you need to do another change. It's inside of the translucency tab underneath here or below in the lighting mode. And you want to change the lighting mode from volumetric non-directional to surface translucency volume. Click it, and then you will see once the shader compiles again, click save, you have the metallic, specular, and roughness pins or nodes back. Now, what we learned from the basics, this is how you set up a simple shader and a simple material. And also when it comes to opacity, we could definitely say, hey, that's exactly the same. So we want to give our opacity input node now a specific value. By default, create another constant. You see here the value 0 is in. It's completely transparent and we wouldn't see anything. So if I type in 0.5, we kind of get the look of a glass, but as you can see, it is kind of semi-transparent, but it doesn't really look like a true glass. And the reason why is because, as I showed you previously in all the other materials, we need to make sure that we have a fall off to the edges, that somehow the material looks in the center more transparent, and as more as you go outside to the edges, and you want to have it less transparent. How can we do this? Well, we apply the same techniques I showed you before. We create a lerp node and we blend in between. We blend in between two different values. But what I would like to show you first is what color actually does in the opacity slot. So for that reason, we create another constant 3 vector. And when we leave it black and we connect it directly to the opacity slot, then you can see that black means it's completely transparent. So if we create another constant 3 vector node and we push this completely to white and we connect that to the opacity, then you can see it's the exact opposite like we had it before, and it looks like completely solid, and in this particular case it looks like a chrome shader. So what do we want to achieve? We definitely want to achieve and say like, look, at the center of the sphere it should be more transparent, so we want to have more black color, and as more as we look at the sphere and the fall off curve goes more to the edges, we want to have it less opaque or less translucent. That means we want to have more of the white color. Again, we create a lerp and we try to blend it with a Fresnel fall off for this. So this would be the inner color and this would be the outer side. Okay, so we also disconnect here, break the pins to here, and then once this is done, we want to control the blend between black and white, the fall off, with a so-called Fresnel node like I showed you before. And for that reason you create the Fresnel node and you connect it to the alpha. And then of course we need to control the strength with, again, a value, a constant value. And let's say here we start with a value of 1.6. Now if you connect now the output from the lerp to the opacity, you can now see how this glass behaves, and it looks much better than glass. So this is kind of like the principle of the opacity you can use. And of course you can also change here the glass color in the base, and then also influence at the same time kind of like the color of the glass or the tint of the glass in this particular case. Okay, so and last but not least, there's one more major check you have to do. Once your material is created like you want it the proper way, you also need to make sure that two-sided material is checked. And this is very important that you do so. And then I show you also in the viewport and here from the material editor that there will be still a difference, because also ray tracing is not supported here in the material editor, but we have been setting up a ray traced scene file here, of course, for the project. And you also have to have the geometry support, which we do not have here with the simple sphere. But anyways, I'm going to show you the effect on it and what you have to do here to make sure that a basic glass material with opacity is going to work for you in this project file. Before I showed you also the post-process volume is very important. Because it determines how we are going to see things in our game. And as you can see, when you even run the game right now, that glass material looks of course different as it looked in our viewport. What you want to do is doing the following. You first of all want to make sure that the translucency is going to be retraced and not on raster. And you can clearly see here this big difference. I mean, check this out. If it's checked on with ray tracing or turned off, it looks completely different. The other thing I wanted to mention is that this sphere doesn't have a double geometry, so you can clearly see that the shader, the material we created, behaves correctly because it's not a double-sided geometry, and of course it looks like the reflection, it's flipped. So the sky is on the top and actually the airplane is on the bottom, and it should be the opposite. You can only fix this by changing the geometry or have a proper geometry that has normals facing to the inside and normals facing to the outside. So if you want to know more about opacity and refraction and glass shaders, I created another tutorial for that goes a little bit more in depth and explains everything with other project files and examples how to set this up properly. But this is the proper way, in a short way, also for a beginner, to get it done right. This is how you can also control opacity, and that should also help you to create all the shaders you need for your game. Alright, and then for materials, there is one more important thing I would like to show you. And it really rounds it up because that's how you have to use or should use materials in your project files. So we have been talking about how to create all those materials, but actually what you want to do is you want to create a so-called material instance from any material you created in the past. And once you created a material instance, then you assign that material instance to any of your actors, to the geometry you would like to change. And I'm going to show you right now how to create those material instances. Alright, so based on what you learned so far, I created here another master material, and as you can see, it's very simple in the setup, but it's just to demonstrate you how to create a material instance. But in order to do so, we have to make adjustments and changes in the material itself. And only if we apply those changes, then this material can be used as a material instance. So for example, you learned that we created a constant value node and we connected those constant value nodes to our material input slots like a metallic, specular, or roughness. Now, what you have to change with all those nodes to make it scalar or to make it a variable node is to change it from a constant to a parameter. And that can be done very simple. Just click on the node. For example, we have here the constant that is connected to the metallic. Right mouse click on it, and you see in the menu below here, convert to parameter. So just click on it. When you do so, you can see that the node is also changing and you get also more attributes inside of your details panel. First of all, I would change the naming of your parameter. So like in this case, we can say this is metal, and then you do this for everything else. You convert the specular to a parameter, call it spec. We do the same for the roughness and so on. Now, whatever you would like to control, this is what you convert into a parameter. And for instance, as well, the emissive color, if I want to change this, convert to parameter, I rename it to intensity of glow. We continue changing all those nodes, also our constant 3 vector nodes. We call this here inner color, and then we convert the second one and call it outer color. And once everything is done, you click save. Now, in order to create a material instance, you can close this and you go to your master material and you click right mouse button, and then you see on the very top you can create a material instance. So we do this and just call it whatever you want to call it. You can say my first instance. So once this is done, click file, save all, and then assign that material to, for example, that sphere here. When you double click now the material instance, you will see that the user interface and the details panel has changed. But here comes the good news, and this is the wonderful part. We can see now that all the parameters we have been defining inside of the material are available in that specific parameter group. For example, if you would like to change the inner color, all you have to do is check and turn on the inner color and change here the color from pink to green, for example. And you can see how you can adjust that shader immediately. Now, this has the advantage that the shader doesn't have to be compiled again and you don't need to go into the network. Instead, you can use the instance immediately to create whatever you would like to create or to make the proper adjustments to your shader. So if I want to have this more metal looking, you increase that value. You also have here an intensity glow value that you can really make this glow. And for example, if you have been missing something, you can always go back to the parent material, because the instance material shows you, look, the parent material is the master material we have been creating here. Now, as you can see, if I would like to change in my instance material the glow color, but I missed the color, right, for the glow intensity, then you have to go back into your master material and also make sure that this color node is going to be converted to a parameter. And then you can say glow color, and once you do this and you save it, you can see that the shader is going to be compiled again. And now when you click into your material instance, you can see that the glow color attribute or parameter becomes available. So what you can do is you can change this from blue to yellow to green to red. It really doesn't matter, but you can see that now you have the possibility to change your material attributes and the values of the materials inside of a material instance. We can also check this out immediately in the game and see how this affects our gameplay. And as you can see, we have a wonderful glow effect here, and it's fantastic how quick and fast you can change those materials. As promised before, I also would like to show you the so-called Quixel Bridge plugin, which is an application from Megascan. It's free to use for Unreal users, and it's a wonderful way to create super quick and fast materials, but you can also import 3D assets to your Unreal Engine game. I created already another in-depth tutorial how to install the Quixel Bridge plugin, so I highly recommend to watch it. And once it's installed, you can use it in a very quick and fast way. So let's get started and let's dive into this. First of all, you can browse here through different collections. And as you can see, there are many options you can choose from. For example, I can click here on Canyons of Utah. And when I do so, I can also see, well, there are 3D assets, there are 3D plants, surfaces, decals, atlases, imperfections, and so on. And I can choose from whatever I would like to use in my project. So for example, if I would like to use that particular rock formation, I click on the download button. Now it's downloading the assets in a way I have predefined in my download settings, in my global download settings, and I can also click then export. So once this is done, you see also, and it said, okay, exported successfully. You can open your project file and then see here a folder was created automatically called Megascans 3D Assets, and you can see what was downloaded. So I click File, Save All, and all those new assets are instantly in my new game. So I can drag and drop here the static mesh to my canvas. And if I start my play, I have this wonderful asset immediately in my game. Now, it's not just that it's great for 3D assets. I have to say so, it's a wonderful source also for surfaces. A surface is nothing else what we learned before as a material. I can download all different kinds of surfaces. So for example, I can have asphalt, plaster, rock, stone. There are so many materials that have been pre-made and you can use for your scene file. For example, let's say I would like to download the dirty herringbone pavement. I click on the download option. Then you can see that the material is downloading. You see here a progress bar. And then again, just click export. And when you do so, it's the same process with a material as it is with a 3D mesh. And after it's exported successfully, you can open your application and see here it is. You can again say save all, so all the texture maps and materials are imported. Now drag and drop this material instance to one of your assets or actors, and you can see how cool that is, because if I start immediately the gameplay, I have here a wonderful material created that just looks really fantastic. As we learned before, you can double click that material instance and you notice that the Megascan assets have already material instances created for you. And this is wonderful because you can control now various options as we learned before. You can control, for example, the roughness, and you have values here. You can change and make it more glossy or less glossy. As you can see, it's very cool. You also have all different kinds of texture maps that are coming with this material, and you always have a default material that's the parent material. And I don't want to go here in depth into those parent materials, how they have been set up, because it's a beginner's tutorial, but it helps you to use those materials in a very fast way, and you can apply it to get everything done in a very short period of time. You also see here, for example, you have the detail normal strength or the normal strength. You can activate this as well, and then you see how nice it is if you want to control the strength of it. And as we learned, if you save this and apply it, you see those changes immediately on your asset or on your actor and in the gameplay. And when you look at this, it's really fantastic. I mean, it's a fantastic way to create any kind of environment in a very short period of time. Another additional material option I would like to show you are so-called decals. So you can choose it here from the tab, choose decals, and then whatever you would like to use. For instance, here I use a graffiti, and then click on the decal you would like to download, and then select the resolution you would like to export to your project file. So once it's in your project, all you have to do is, it's a material instance, and you drag and drop it on top of your object. You can see here in the world outliner, it pops up as a decal actor. And it's pretty cool because you can move this around, and as you can see, it wraps around the geometry, and it is not really attached to the geometry. It's attached to the world space, which is pretty cool. And of course, you can scale that decal, so you can make it larger and you can make it smaller, and then you can move it up or down and make the proper adjustments so it fits to your geometry. You see here I have other graffitis brought in, and it's really cool because it allows you to add a lot of details in a very short period of time, and you can do this very, very quickly. You also can find atlases, but atlases are working for foliage, as you can see here. And then you have imperfections, also displacements and brushes. Another tool I would like to show you is called Substance Source. So this tool is similar to the Quixel Megascan product called Bridge, but unfortunately Substance Source is not for free. But what you can do is very, very similar. You can download materials from their source, so from their website, and bring those materials immediately into your game engine. For example, I can download here the bamboo material that is for free, and you can see that when downloading those materials, I recommend downloading a so-called SBSAR file. And when you do so, you can simply drag and drop this material into one of your material folders you created. So I, for example, created the substance material folder, and then all you do is drag and drop it into your folder, click import, and it's importing by default the material settings. Click save all, so everything is in your project saved, and drag and drop it. And when you look at this, you can see that it also created a material instance, and as we know from the previous learnings, you have also here different settings you can control, and it basically works the same way like the Quixel Bridge plugin. You can also launch the plugin from inside of Unreal. If you click the icon, it will open, so to speak, the browser, and once you logged in, you can then also download those materials directly into your Unreal Engine project. Another great way to use pre-made materials is, of course, the marketplace from the Epic's game launcher. You can search for on the marketplace and then add it to your library. So for example, I downloaded or added, for example here, the automotive materials, and you can simply add all those materials to your project by clicking on add to project, and then select the beginner tutorial. That's the project I'm working on right now, and then click add to project. You can see the download works pretty fast. And once this is done, you go back to your project file and you can see here, I already imported a free car. I also want to give Karol Miklas the full credits for this wonderful free car you can download here on Sketchfab. And I imported it as I showed you before. You go back here and you can see now the automotive materials package I was downloading for free contains a lot of different folders. For example, you see here master materials and materials. When you click on materials, you see also exterior materials. You see those materials are pre-made materials for the automotive industry, of course, and it's just another way to get things done very quickly. And especially if you're a beginner, I show you how you can use those packages. So you simply drag and drop it to your car, and here we go. You have that wonderful blue car paint material assigned to your car, for example, or you exchange it with another one. And so on. So you can see that it's really great to get very quick results. And if you click the play button, you can definitely see, yes, it works fantastic. You can run around in the game, and yeah, it's a very fast way to get things done. So the next interesting chapter we can attack now is lighting. When you followed this tutorial, you could see that so far we only have one lighting actor in this scene file, which is the so-called HDRI backdrop. So if I delete this HDRI backdrop here, you can see the scene is completely black because we do not have any other additional light source. So let's get started from scratch and let's drag and drop the HDRI actor or backdrop onto our canvas, and let's see what we can do with it. First of all, when you look at this here, you can see that it already contains additional components, and you can see this here in the details panel. So below the HDRI backdrop, you can see we have scene components, geometry, and skylight. When you click here on the brush wireframe, you can see that this is nothing than a dome, a geometry, and the HDRI is a texture map, a high dynamic range texture map that is applied to it. And that illuminates the scene and helps also for the reflection. So when you look at the options of the HDRI backdrop, then you can see that you have XYZ coordinations, of course, for the location, and you also can scale it, and you have also below here in the details panel the intensity of the light value and the size. For example, the size means if I blow this up to 500, my geometry, my radial geometry I'm actually working with just gets extended and gets larger. If you bring this back to 150, you see it shrinks down and it gets smaller. You also see that, and this is very, very handy for the projection, you get here this little projection node, and that is really, really cool because by dragging and adjusting this projection center pivot point, so to speak, you can align the horizon line from this projection on the dome, and that helps you to make the proper adjustments and make sure that the texture map is not distorted and it's right in place. So one important point, of course, in the lighting using the HDRI is also the intensity of the light. Light values is many, many times completely misunderstood, and I think that's a very, very important chapter or very, very important component of lighting. For example, when you look at the HDRI, we have an intensity value of 1. Now, a lot of people get confused because they say, wait a minute, when I'm using, for instance, directional lights in combination with my HDRI backdrop or with the sun and sky system, you know, things are not working out for me because it's either underexposed or overexposed, and I don't understand this, and then I have my camera values and so on. So what you have to understand is that an HDRI backdrop is a fake lighting. So it's not a physical 3D light source, so to speak. It's more like, hey, we are going to fake it for global illumination and also for the reflection. And those light values you can see here by default just have the value of 1. And that means if you would use the sun and sky system, which I'll show you right here, right after, in combination, you will run into a light value problem because the intensity value of the HDRI will never match with the sun and sky system unless you make those proper adjustments. But before I dive into this, let me show you also how simply you can exchange your HDRI backdrop. So you can download free HDRIs, for example here hdrihaven.com, and then whatever you would like to have in your scene file, just download the proper HDR file, and then once you have it on your local hard drive, create another folder. I create one here and I call it HDRI. And once this is done, you click add import, and then once you have this, just simple exchange it by dragging and dropping it to the cube map. And when you do that, you can see it was exchanged. Another thing I want to clarify is it really matters with what specific resolution you're working with your HDRI. And if it gets blurry because you have the level of details set from the texture group, right? You want to make this change here and say like, you know what, choose it with no mipmaps. So that means the resolution will not be reduced. And then you can specify the resolution, the minimum resolution you would like to use it for the projection. For a final project file, of course, depending on the RAM, the GPU RAM you have, I recommend using higher resolution maps. But as you can see, once this was brought in, then you also have again the projection center node, and you can make those proper adjustments. And then here we go. So, and now let's have a closer look to the so-called light values, because they are very, very important. As you can see, you learned now how to exchange an HDRI backdrop, and you can choose whatever scenario you would like to use for your project file, right? And what happens now when we want to control our own sun and sky system? Because, you know, the downside of using an HDRI backdrop is, of course, that it's a texture projection. That means the clouds or the trees here, what we can see, it's just a texture map and we have no control over it. But if you get in a more advanced lighting scenario, it would be fantastic to control this and to have actual physical actors to have a total control over your lighting scenario. So in order to do that, you can use the so-called sun and sky system. Now, when you do that, have a look what's happening, what's happening right now when you drag and drop it to your canvas. As you can see, it blows out immediately and a lot of people get confused. First of all, when we go inside to the sun and sky system, look at the components below, we can see there is a compass mesh inherited, there is a skylight, and it includes automatically a directional light, and there is also a sky atmosphere light. What really blows out this scene file is, of course, the directional light, and the directional light is nothing else than the sunlight. Now, when you look at the intensity value of the sunlight, you can see that we are using 75,000 lux values. And that is a complete different value from the HDRI. And this is where the mismatch comes. Now, you have, of course, now the option to say, wait a minute, I would like to make the proper adjustments to my scene file and say I would like to adjust, or I would like to light my scene file with the values, the intensity values from a sunlight. So for example, the 75,000 lux intensity values, it's kind of like a number that the developers from Epic have been using to simulate sunlight. It's a measurement. It's one value to say like, look, the intensity from the sunlight is so strong, right? We're working with 75,000 lux values. Now, of course, when you go now back to the HDRI, you can see that we have only an intensity value from 1. So that means you will never be able to see it because the sun is completely overexposing it. Another problem you have, and I showed you before, is, of course, in the post-process volume, we have a physical camera and we set our camera to manual exposure. And what we can do is we can bring down in the post-process volume the exposure of our camera. And if we do so, you can clearly see, yes, we are getting now the proper exposure, because if you would be outside with your camera and the sunlight is so intense, right, we can make those adjustments. But as you can see, if it's in combination with the HDRI, you will still run into a big problem, because even so, if you make now the proper adjustments, the background is dark. And the reason why the background is dark is because the HDRI is not matching up. And it's not matching up simply because the intensity of the HDRI is just set to 1. So now let's increase this by 100 or by 1,000 or 10,000, and you can see, whoa, this actually will work if we make the proper adjustments and we assign a proper value, for instance, 1,000, 5,000, 10,000, to this HDRI. So, but another problem you will run into is, if you would use it in combination, is of course that the light source is not going to match. That means the light source of the baked HDRI is different than the light source from the sun and sky system. And what does it mean? So let's go back here and I delete my sun and sky system, because you can always bring it in very simple. And then let's focus on the HDRI here. Just select the HDRI backdrop, and let's say we have an intensity value from 10,000 right now. So we can see the exposure kinda is okay, but we can also clearly see that when we are looking at this HDRI, right, that a sun position was burned into this texture map. And the sun position, when I look from this particular angle here, would be right here. If I use here basically like a clock system, I could say at 1 o'clock from here, the sun has its actual physical location. And that means the baked information from this HDRI contains this information, and you can only change it by rotating the HDRI, right? Or by keeping it like it is. But if you are going to add now a physical light source, and the sun and sky system contains that physical light source, which is nothing else than a directional light, you want to make sure that it comes from the same direction to match it, right? So this is, of course, for many people, oftentimes misunderstood or not considered. And that's very, very important. Let's get back here and drag and drop a sun and sky system into this project file. And then under the directional light, you can now make those adjustments. So if the sun would be somewhere here, right, that means that the shadow will be casting towards this direction. And to make those proper adjustments, I turn off my HDRI backdrop, and then you can see this is just the sun and sky system. Okay, and now what I can do is I can make those adjustments. Look where the shadow is right now. When you look at the car, the shadow is in front of it, so that means the position of the sun is wrong, is off. And to change this, you can select the sun and sky itself, and then you have here latitude, longitude, and time zone information. You have also date, month, and day, of course. The most important thing is that, of course, you start making those proper adjustments. And as you can see, when you change the longitude or latitude, you definitely can control the shadow or the position, of course, of the sun itself. So when we do that, when I position my sun, you can even see here a nice sun reflection. It should be somewhere up here, right? So, and you play around with the settings until you have something that kind of simulates the HDRI you have in mind. You see here the sun is already here, and if it's at 1 o'clock somewhere up here, so the sun would be somewhere in this position and location. Now if you turn on back the HDRI backdrop, this will match, okay? And all you have to do then is in the post-process volume settings, of course, you have to make proper adjustments from your exposure in general. And if you do so, you see, aha, it's getting there, because the light atmosphere, the light position from that sunlight, that is matching now this position much more, and everything feels like it's much more integrated. Okay, so this is the very, very first lesson and important part in lighting your game level. And when you click now play, you can definitely see, first of all, the reflection from the physical sun source on the floor. You can see here also kind of really fits to the position from the HRI backdrop. And of course, if you would make now changes to the HRI backdrop, you also need to make those changes and adjustments to the sunlight. But as you can see, when I go to this car here right now, and I look at my overall look, it matches much better. The HDRI and the sun system is so much better integrated, and it looks much more realistic. All right, and now let's have a closer look if you want to use just the sun and sky system, and if you don't want to use any HDRI backdrop. As I said before, the HDRI backdrop can limit your scene file because it's a baked texture map. And what if you would like to have different lighting scenarios? What if you undecided from the beginning of your project if it should be a day shot, if it should be a sunrise or a sunset shot? So I want to show you how to use a project and a game without an HDRI backdrop, and how powerful it is just to use the sun and sky system. First of all, you saw now how we are setting up the sun and sky system. Go back to the sun and sky system here. All I did in this file, I was deleting the HDRI backdrop. And then let's have a closer look here to the sun and sky system again. What is super cool, as I showed you before, is that you can make those proper adjustments just in real time by changing the latitude or longitude. And that's super cool. You can also, of course, change in the directional light the source angle of the light source and also the softness of the shadow. So if you make those proper adjustments, you can really, really look at this. Go into more detail and say like, hey, if I change my source angle from 0 to 5, I can influence my shadow line and it looks much softer when you look here on the edges. So that is super cool too. But what most importantly is changing a lot is the fact that when you look at this scene file and you just have the sun and sky, it looks a little bit naked. And the reason why is because we don't have any volumetric clouds. But luckily, also Unreal Engine, the Unreal Engine is so powerful that you can also add those volumetric clouds in a very easy way. First of all, under the plugin settings, make sure under built-in that the volumetrics is enabled. Okay, that's a library. You can choose from different blueprints and presets. You can just drag and drop. So once this is done, so search under the play sectors under cloud and you will find volumetric cloud. So all you do is drag and drop it to your canvas, and look at this. You have automatically here a wonderful volumetric cloud system integrated. And as you can see, that volumetric cloud system has a material, a very complex material assigned to that is again an instanced material, and you have multiple options here to make proper adjustments. You can change the scale, you can change the speed of the clouds are moving, and so on. But I don't want to get into any specifics because, of course, as you can imagine, that shader network of that cloud system is very, very complex. This is a beginner's tutorial and it will help you to get started relatively quick. Of course, feel free to play around with all those different settings inside of the instanced volumetric cloud material. But as you can see, just by adding that, it helps a lot. And of course, if you using this for an exterior scene in the gameplay, for architectural visualization or whatever, you can make those proper adjustments. And yeah, it's really cool because you can achieve various looks in a very, very short period of time. So as you can see, this looks fantastic. Okay, and because I love lighting so much and I want to show you how impactful and how powerful it is if you know all these basics, what you can do in a very short period of time. For example, let's say you want to change this environment here, and let's say, you know what, we bring in a sand and we want to change the environment. We have another cool idea. Then I'm going to assign a new shader here, a material. So this is sand. And then there is a cool feature also on the plugins. If you go to built-in and search for water, that's experimental right now, but it's super cool. Just make sure it's activated. And under the play sectors, search for water, and you can now drag and drop a so-called water body custom to your project. Look at this. You get here a tiny little plane, and you can also position it 0, 0, 0, and then make it, scale it up 100 and 100, adjust it and bring it up. Look at this. You have water in here, which, how cool is this, right? I mean, look at how quick and fast and simple you can create something. It's wonderful. And I also showed you, of course, how to bring in different assets. I also prepared a little boat here. And if I turn this on, let's have a look at this. And you have immediately a wonderful shot and a crazy cool thing here in this game. So if you click play and you want to check it out, you run on the sand. There is the water. There's the boat. We have a car. We have a jet. It's just fun. It's amazing, right? So I hope you enjoyed it so far with the lighting, and then we jump into the next lighting features and options. I want to introduce you a little bit, of course, to point lights, spotlights, and rectangular lights. All right, I would say let's jump straight into lighting, and for that reason I created here a new level. It's just called room, and as you can see, I put in our room a lot of different assets. So here we have a seat from an airplane. We have some scanned data here. You know, if you're like interested in creating levels for a museum, we have an interesting skull that was scanned here as well. I have an engine and I have a game character, a really nice one too here. Very, very cool stuff. Or using the Unreal game engine, it's not just all about gamers anymore. It's also for, you know, product visualization, VR experiences, and whatever you would like to design. Especially designers are benefiting a lot, because if you want to create different material studies, you can assign different materials. You can change the lighting in real time. For example, this space can also be, imagine like a pop-up shop, a retail in space, an interior design. So product visualization, whatever you would like to show. The Unreal Engine is for that purpose a fantastic tool, because you have all those options and possibilities. Yeah, if I go to unlit, then you can see I created here right next to it another room. So we have all the assets over here, and I created another room. And when I turn on the lighting, so there is nothing. So we can start using for the lights here a so-called point light, and press G, and then let's go to lit. And then you see how we are getting started here looking at our light source. So the first thing I want to show you is, of course, we have here static, stationary, and movable. I spoke about it briefly before. This is specifically then for runtime in the game engine, very important. But for the beginner tutorial, I would say it really doesn't matter if you work for now for stationary, static, or movable. One thing I want to mention as well in the world settings, make sure what I said earlier, that we have here force no pre-computed lighting checked. That means we don't bake anything in this tutorial. We are not talking about baking, not talking about light mass or anything like this. And we are totally focusing now on lighting. So the first light source that you can find on the lights here is a so-called point light. And as the point light points out, you can see here there is also a radial fall off. You see this here on the lines on the blue wireframe. And you can identify a few things, of course, here when dealing with light. First of all, if you keep it static or stationary movable for this tutorial, it really doesn't matter. But let's check a few important values you should definitely understand when doing your lighting job. First of all, we have intensity. And as I explained before, intensity values are very, very important. You have different values, of course. This one is measured in candela. So by default, so you can change here the intensity and set up the lights accordingly. You can also, of course, change the color. And when you apply a different color to your light, it has definitely immediately an impact to your mood. The next important part is, of course, the so-called attenuation radius. Let's call it fall off. That's easier for me. And as you can see, if I increase this fall off or if I decrease this fall off, I can narrow the fall off curve, so to speak, or radius from my light source. So this is a very important one. And as you can see, I can influence how far my light is actually spreading. The next important part is, of course, the source radius. And when you look at the shadow, you see that we have a very harsh line here, very harsh shadow. Now, when you are going to increase the source radius, you can see that you can influence now with the source radius the sharpness of your shadow. That is super important, because if you want to create a specific lighting scenario, then of course, understanding that I get a more soft shadow, more soft light, or like a harsher light, and that is influencing my scene, that is very, very important. You can also see here the soft source radius has an extra value. And when you change that, you can see it on reflective materials. Let's have a closer look here. This is a chrome material, how the impact is. Okay, so if you keep the soft source radius sharp, you have a sharper impact. And if you soften it, you see how it's softening, so to speak, also the reflection of your geometry. But it's basically a softening of the reflection. And of course, lights do have a strong impact to that. So you can also change the source length. As you can see, I can make this more like a tube. I can rotate it and change so also the impact or the size of my light source. You have then also here temperature changes instead of color. So if you make it warmer, you bring the temperature number down. If you want to have it cooler, you bring it up. But that's totally up to you. I prefer to use just the light color. Of course, affecting the world means, hey, it should affect the world or it shouldn't affect the world. And yes, it should cast shadows. Or maybe you prefer to turn off those shadows. Then visible is the same effect also for rendering. And one important factor I want to show you, of course, as well, is any light has that is are the so-called samples. And most of the time, people don't really think too much about light samples. And let me show this here to you. When we increase the source radius, you can clearly see that it starts like getting very noisy, right? So by increasing the light samples, look at this, and I change this, let's say, to 16, you can see that with 32, the noise disappears and you get a very smooth and clean render. So then another important feature I would like to show you is pretty cool, are so-called lighting channels. So for example, when you select the light here and you type also in channel, you can see that you have different channels you could use this light. But this only works if the light definitely is set to dynamic and if you set it to stationary. What is a light channel doing? It's very cool feature and option. It's basically a layer, and you can include or exclude geometry objects from your scene file. So by default, everything is illuminated by channel 0. And you can check this by selecting, for example, here the cylindrical shape and form. And then you can see it's illuminated through the lighting channel 0. If you turn this off, it's not illuminated through this lighting channel anymore. Now I can say, you know what, I want to illuminate this by lighting channel 1. And if your light is also set to illuminate lighting channel 1 only, you can see that this light is only affecting that geometry. The next thing we have here is also a so-called rectangular light. It pretty much behaves similar from features like the spherical or point light, but you have a few other options here I would like to show you. So first of all, it is rectangular, but everything else in terms of the mobility, you always have those 3 options. Either it's static, stationary, or movable. You have also intensity of the light, and we can also turn this light here off, effects world. So for example, poof, we snip it off and then focus just on this one light source. So as you can see here, we also can control the so-called blurriness or the softness of the shadow with the size, because look at this. The width and the height from this specific light is by default right now 64 and 64 units. So by decreasing that number and you make this light very, very small, you can see now how sharp that shadow appears on the floor. So additional to that, as you can see, you have a barn door and barn door length included. So that speaks for itself. When you change here the values, the angle or the length, you can control here as well the fall off from that specific light source. So you have then also specific texture maps you could load. You can again change like the temperature and change also of course the so-called samples. If you want to make the shade or the shadows like noise free, then you have to increase the samples. So those are the basic elements in terms of lighting I wanted to show you. Anyways, what you also can see is in this interior shot, I wanted to show you how you can light something very, very cool. And a lot of people asked me before, Bernhard, what is going on? How can I do like, you know, for example, architecture, interior lighting? It can be also just one room, one space. It could be for one event. It can be a retail space. I mean, there are so many different options, right? In general, people tell me, look, Bernhard, when I start my lighting and when I do this and I have ray tracing on, it really doesn't look like this is real or realistic. And lighting, of course, is an artwork itself. Again, one more thing I wanted to mention here is in the post-process volume, because we have ray tracing always turned on. I want to show you something here, what I do for interior. First of all, when you use the post-process volume, you can see that you can turn on global illumination. And here it's still turned off. Now let's have a look when we turn this on, what it actually does. You can see it here very slightly on the edge of this armrest, right? When you turn it on, you see it brightens it up. That means right now there is one bounce. So a ray comes down and is bouncing off in real time and bouncing off from the red carpet to this armrest, and that illuminates the armrest. So that means especially for interior lighting, global illumination is very, very important. Now you have here 2 different algorithms to calculate it. One is called final getter, and then you have one it's called brute force. So both do work. I always prefer in most of the cases brute force, even if it's for sure much more performance intense, but it's nicer for the noise to control, and it helps you to clean out things for final renderings and animations. But this is really up to you. You can use also for the preview final getter, and then you can go on and change this to brute force. So this is one thing. Another cool thing I wanted to show you is even if you turn this off under the project settings, you have also a so-called global illumination in your overall settings, global illumination. And this is a fake global illumination. It's a so-called screen space global illumination. As you can see, it's in beta. But the cool stuff is also you see it here just very, very slightly as well. When you turn it on, what it does is it helps to illuminate the dark areas a little bit, and it takes from the screen space somehow the GI. You see it also here on the edges a little bit, very slightly. You can see also the the effect on the side of the cylindrical form. So when it's on or it's off, you see the red bleeding here, and we can go here a little bit closer so to see this difference. So it's on and off. So this is a fake GI. I like to use it for interior scenes. It also helps you to brighten up those things and make it a little bit more realistic. So then people ask me still, look, Bernhard, for product photography, product presentation, interior scenes, whatever, this is still not for me like, hey, this is not how it's supposed to look, right, in reality. And this is because you need to do your lighting job. That means a lighting job has to be done no matter what. So when you have dark areas and walls like here, they are black, right, and there is literally no light, then you have to create different light sources with different color variations and different fall-offs, because this is how reality works. So when you compare now the other room, you will see that I literally created just different lights with different variations of color and intensity and spread it out in the room. And when you do so, that gives you then this effect that the room looks really, really photoreal, because you need to have different light sources with a little bit variations in colors and so on. And when you do that, that helps tremendously. I make this short and jump over to the other room on the other side, because as you can see, I turned on lighting with G, and you see all the light sources, but all those lights, as you can see, are multiple spherical or planar lights, and this is how an interior scene would look like. So because of the different bounces and the different variations, it gives you all those highlights, and it looks very, very real. And yeah, it gives you all the options, and it's really, really cool. Okay, so how does it look like if we play this game? If you click play, you can see, yes, this looks actually phenomenal. I mean, look at this. This can be like an event space where you show different things. The lighting looks really, really cool. This is all in real time. And yeah, I mean, as you can see, the lighting really matters. And I hope you also like this, and that this quick tutorial or the beginner's tutorial and lighting guide also helps you to create different levels with different ideas, no matter if you're in the automotive industry, in the game industry, if you're in general a visualizer, if you like retail design, if you're in the aviation industry, if you're a designer and so on. You can see you can use this for multiple purposes, and it's a lot of fun, and it's very, very powerful. That can give you quick results. All right, and now let's jump into the next exciting chapter. And this time, as I promised, we are talking about the sequencer. So if you don't see the sequencer tab here on the bottom, you can click on Window, Cinematics, and then here you see the sequencer. You can turn it on or turn it off, and then you will see that it's popping up here. First of all, you also have in the upper tab here the so-called cinematics, and then you can see you can add a so-called level sequence. By doing so, you give it a specific name, you can organize it, and you can save it, of course, in any folder you like. I call it just sequence 001, and I save it. Boom. So here we go. Once you did that, you see that you get a so-called timeline. And you can specify the timeline, of course, where it should begin. You can type in here 0, and then you can say, hey, I would like to end this timeline, let's say at 5,000 frames. You can also drag and drop the red line marker here, and then you set it all the way down. And as you can see, the sequencer works like literally also like a recorder. So you can press the play button, you can play it backward, reverse it forward, you jump in between, and so on. And you can also loop an animation or any sequence you're trying to play here. Another exciting thing I want to show you is, of course, that you have here also the so-called curve editor. And I will show you later on why this is important, why I'm going to use the curve editor, and how I use it, and why it's a pretty cool thing to have this inside of your sequencer. Now, what is the sequencer helping you? The sequencer is basically helping you to animate actors, any actors you have in your scene file. That means whatever you create, whatever actors you drop into your game, you can, so to speak, add to your sequencer. Look, for example, if I say this cylindrical object, this cylinder, I would like to add to my sequencer, all you have to do is you select it and then you drag and drop it onto your canvas, right? So now you can see you get some basic elements or like features and nodes into your sequencer. You can see here the transform node. For example, I can then specify location, rotation, and scale. And that means when I have this sequencer activated, let's do just 500 frames for the beginning, and I drag this out here, I can set now keys. And that means, for example, if I want to animate a sequence from the cylinder, I can set a key by pressing this key button here in the location. And if you open this, I set now a key in the X, Y, and Z at frame 0. Now I can move this forward and I can say, you know what, well, let's do 500 frames, not 5,000. And I can move this forward here and say, hey, at frame 300, the position or the location of this cylindrical object should be here. So now you would go in and select again and key those frames. And when you, when you go back, you see how the animation actually works. So this is the basics of the sequencer, because you can see in real time how this animation can be done. Now you notice one thing, by default when you do so, and you go to the graph editor and you open the cylinder, you see here the transform node, you can see that every animation, if you're a little bit familiar with animation keys, has curves. By default, there is always an ease in and an ease out. So you can see we set a key on the X transform node, and you can also see that there is a curve, and it's an ease in and an ease out Bezier curve. But you can also create this and change it by making it linear. And if you do so, you can see here, and if I also change now this and move it back here a little bit so it goes a little bit faster, you can see now the animation starts linear from the first and goes literally to the very end in a linear way. So, but why am I showing you the sequencer? You can add now different actors, of course. It's not just because it's great to animate geometry. It's also great, of course, to have then actors and characters in your sequencer with the biped system. What I would like to show you and introduce you is now adding a camera to the sequencer and then really checking out what you can do with the camera. So what you can do here, and what we are going to do is now, let's add a camera. You click on the camera icon and you can see immediately a camera was added to your sequence. Now you have a few controls here in this camera, and you can also see once you do this, a so-called camera cuts track is going to be added to your scene file. And that basically means that when you look through this camera here right now, which you can see it's called a scene camera actor, right? Then you can see that this scene camera actor was also added to your camera cuts track. And basically you are looking through this physical camera right now. You can see it looks already pretty cool because you can see it's a little bit blurry and it behaves like a real camera with a real lens. The reason why is because the manual focus distance is set to 1000, and if you change this here, you can see, then you can change now immediately also the focus distance, okay, of this specific camera. And as we all know, cameras, it's for sure like if you're a photographer, you are familiar with camera settings, or a DP, a director of photography, you definitely know how a film camera or like a digital DSLR camera works. But you know, for a beginner, I just want to show you the basics. And I would say if you would like to know more specifics about a physical camera and film camera and how to use cameras for cinematography, I also created an in-depth tutorial that shows you just many more things and features, how to use a camera to get a cinematic look, also of course with lighting and so on. So I definitely recommend checking out all my other videos. But for this beginner tutorial, I want to give an introduction how to use the sequencer with the most basic features, and also how to use a cinematic camera, or like a cine camera, and what you can do and how to make those proper adjustments, and how to bring also features and values from that cine camera actor over to your sequencer. So let's go through this. You see also that any camera has, of course, a position and a location. You see it here. When you move it, you also see that the values under the in the details panel here below, you see the location is, of course, changing. You can also see the same here in the transform node that is automatically here. You have here X, Y, and Z, and then once this is adjusted, it's also automatically adjusting it here below in the sequencer. And of course, you have the same in the rotation, so you can roll the camera, you can pitch it, up and down, and everything is changing here in real time. You can see this. Of course, you could also change all the values in here and say like, okay, this is how it should look like, or this is where I would like to position my camera. I think one of the most important features, and we will go through all the most important basic features I want to show in this beginner tutorial, is also the so-called film back. The film back allows you to change the aspect ratio. So the film back by default is a 16:9 digital film, I would say like frame. And you can see you have different ones here. You have 16:9 by film, you have a DSLR. This is what most people are familiar with, because that's kind of like the chipset you have on a digital still image camera. And of course, you can change the sensor width and height by yourself. So if I would like to have a more cinematic view, I can say like, hey, I'm shooting here with a 50 to 20 mil film sensor chip. So what else we have here? We have, of course, then lens settings. We can also specify what should be the minimum f-stop there and the maximum f-stop, also known as aperture. You can also change the blade count, from your lens. I like to use 5. I like to use here also like more and go up until 50. You can also change the minimum length from the focal length and the maximum focal length, of your camera, and so on. Now, what is really important to know is, for example, the current aperture is set to 2.8. You can also see it here. That value, what you can see set here in the camera, is also below here in the sequence, in the details tab. You have now multiple settings, of course, and what's really cool is that you can bring any details and any values you can see here and control elements, what you see in the details panel here below your camera, over to the sequencer. So whatever you would like to control inside of the sequencer, you might want to animate it and set some keys. You can bring this over, and I'll show you immediately how to do this. So for example, I like to set also my exposure in my camera to manual. So if you type in exposure, you see below the lens, you see the exposure here, then your camera is set to auto exposure. So if you're not really familiar with exposure settings, f-stops, film sensitivity, ISO, also known for, then I recommend, let's keep the auto exposure on. But you have to keep in mind, for animation purpose, sometimes it might not work out, because the auto exposure is then changing, of course, the exposure settings. And for that reason, I always recommend, hey, work with manual exposure so that you have really full control and set your camera to your lens to a manual exposure. Then below, this is a little bit of a cheat, but it's pretty cool to use. It's a so-called exposure compensation. And now let me show you what is very nice for the beginning. If you're a beginner, click on this little icon here. It's called adds a keyframe for this property to the current animation. So if you do so, check out what's happening below your cine camera actor, because if you click on this, you see that the exposure compensation is now part here of the sequencer inside of your sequencer below your camera, right? And that means you can now set keys to your exposure compensation, okay? So when you change here now the value, and let's say you change it to 11 or whatever, you can now control how this exposure is set with the value. And you see, it doesn't matter if you change the value here to 15 or you change it here to 11, it synchronizes the data because that's basically the same data. Okay, so yeah, let's add, of course, then here the exposure as you want it. And there are many other options. So you can, of course, also change vignetting. And then you say like, hey, I want to change my vignetting intensity. That's kind of like on the edges, the intensity of a fall off. You can add a vignetting. You can also add, of course, a chromatic aberration, change the intensity, and you can see you can crank this up to a crazy value. But I just want to show you what you can do slightly, okay, with some of those features and settings. You have, of course, also here in the camera then a lot of color correction, post-process tools, so where you can individually control each camera and say like, okay, I want to change my bloom. I want to change, for example, my saturation of the camera, you know, of the white balance and so on. You see here shadows, midtones, highlights. You can change literally everything. Look at if you change the intensity of the saturation, right? Or you desaturate it. You can shoot in black or white. So you have all the options for color grading in real time here, and that's super, super cool. So, but now let's dive into this. How can we operate this camera and how can we use it also so for a short and quick camera animation, right? So how can we do this? So first of all, you can see also here on the top, you can always look through this camera by choosing this camera instead of perspective. You have here now the Cine camera actor, right? And when you do so, you see you look through your camera. So if you stop piloting through this actor and your camera is selected, you still see here that, okay, that's the view of your camera you're going to look through, right? But we want to work like this. I love to work like this. I want to literally look through my camera and see what's going on here and what am I aiming to shoot. The next thing is, of course, I can pick my lens, my focal length. So that means you have a very expensive lens here because you can choose whatever you want to choose. It's digital. It's absolutely fantastic, right? Because I can have here, let's say, a 1.8 lens shooting here, and I have a 156 mil on my camera, which is amazing. And you can, of course, use crop factors. You can choose from full frame cameras, anything you dream of. You have everything in the digital settings you can control, and that's really, really amazing. Because if you like to have here depth of field shots with shooting wide open with your current aperture from 1.8, you can achieve amazing shots. And then you have here your focal distance, so where do you put your focus, right? And you can do this in real time. It's amazing. You get bokeh effects. You can see it here, very, very cool, depending on how you change also your bokeh effects, of course, and the blades and the lens and so on. But it's amazing because you get really, really super fast, quick results, and it looks very, very professional, right? So, okay, what is next? What can we do if you would like to animate the camera? Well, that's very simple. As I showed you before with the cylinder, you can also animate, of course, your camera. It's the same technique. You have here transform node, and then you have a location. But in order to not set those keys all the time manually, you also have here some nice options you can change. And for instance, to create keys automatically, you can key all and say like, you know what, I want to set those keys automatically. By the way, frames per second, we are shooting with 30 frames per second. You can change this whatever you prefer. You can change it to 240 frames per second or 24 frames per second like film. So this is really up to you. By default, we have 30 frames per second. That works very well. Let's have a look. If I would like now to animate this camera, I simply go to my transform node, set the key here at frame 0, and then I move forward, let's say to frame 300. You also can type this in. And then I move my camera at frame 300 and say like, you know what? I want to have, for example, my game character here. And I want to set my focus then here as well. But I'll show you this. So you set the first key, and as you can see, the camera starts panning up towards this character until you have this final shots done with the face, right? As you can see, we have a fade in and a fade out. If you don't like this, you click on the camera component, like to the camera actor, of course, you select it, and then you send, we have here like our transform node, and you can also clearly see here we have the ease in and ease out. So you select it, make it linear, and then you see now, if you start this animation, you have a linear animation, okay? So, and you can change all those values in between. So let's say if I want to change my manual focus distance at the very beginning, I change here my manual focus, and let's say from blurry, I want to then have a focus to this character at this specific key, and then I change it and set it to the focal point like here, and you see what's happening, and I have it sharp or in focus, right? And now you see you can play with those values also in between that camera shot. So that means, let's say if I want to have my seat in focus here at frame 65, I just change my focal distance, and then as you can see, boom, it's there. It's getting like, okay, it's sharp now, and so on. And you can change now, of course, like the position of your camera and go then in and animate the cameras, you know, as you want. Of course, camera animation is an artwork itself. It takes some experience to understand how you create cool camera animations, but that's something what I wanted to show you in the sequencer for sure, because I think it's super, super cool. One more thing you noticed maybe, so delete all the keys here because we don't need it anymore. But one cool thing I wanted to show you is also many artists have been asking me this. Sometimes you see here when you blur your focus point, you blur basically when you change your manual focus distance, you blur it out. You can see here that the eyebrows or eyelashes, whatever you want to call it here, something is not getting blurry. And as you can see, this is that kind of piece here. And the problem is the shader is the material. So when you double click on this parent material, then what you have to do is select the material and make sure the depth of field is rendered after. Okay, so the depth of field render after the depth of field, that shader, that material. So once you change this and you save it and you selected it, then you will see that this problem disappears, and you can see now it's blurry. Okay, so once you see this problem occurring through your camera, notice how to change it. It's a material problem, and you can fix this in a very, very simple way. Okay, so that's basically the basics for this beginner tutorial, how to use the sequencer with a camera. Of course, like I said before, you know, it needs more experience and to create cameras, to create camera animations, teasers and trailers. And I'm going to create more in-depth tutorials also how to use the sequencer with a master sequence, how to make camera cuts, how to blend in between and so on. You will also learn later on in in-depth tutorials how to add other additional camera actors, how to create effects, how to add those, how to create, of course, character animations, how to load all those actors into your camera sequence and create more complex shots, so to speak. But for the beginner's tutorial, I think that should cover a lot, that you can start very, very quick, create camera animations, and then also renderings. And how we do the renderings, I will show you right now in the next chapter. All right, now let's jump into rendering. First of all, what you would like to do is go under plugins. And in the plugins, you also want to activate two built-in plugins, and they are called the Movie Render Queue and the Movie Render Queue additional render passes. So activate those, you most likely need to restart. But once you did so, then you can go under Windows Cinematics and you can find here the Movie Render Queue. First of all, if you click on the plus render sign, you see that, okay, we want to choose, of course, this sequence number 001. That is the sequence we are working in. And the map is the room map we created. You can also see up here. So that specifies, so to speak, where would we like to use the render queue, in what specific sequence and what specific map. Now, the second thing you can choose now is the so-called render settings. Under unsaved settings, you see it here, there's an unsaved configuration. You click on it. You see that another window pops up, and in here we can first of all see, hey, is it a JPEG sequence or do we want to have a different output? I leave this for now as a JPEG sequence. We also have here the rendering. By default, it's the deferred rendering process. And then we have also here in the output where we would like to specify where do we want to render that image, right? The still images. I specify usually in my project folder, or let's say like a render output folder, you can see, so it's not within your content. So within my Unreal project folder, create render output, and then there's stills. One more thing that is important here, leave everything by default at the beginning. You can choose here and select, of course, the resolution. This is full HD for now. And the next thing is I would like to override my custom frame range. So we have, of course, a lot of frames here, but you know, if it's a still image, as you can see, I was setting up this camera here with this shot. So let's say we would like to shoot this camera. It's not animated, and we see that this in the timeline, of course, is static. So there is no animation no matter what keys or frames we specify and we define. Click again on unsaved, and then I just say, you know what, let's start from frame 5 and let's render 1, and my end frame is frame render 6. So click accept and check this. You have render local, click on it, and when you do so, it starts rendering. Boom, this was the whole process. Then go into your folder. This is the still image we just rendered. This is one way to do it in a very quick way. Another option is, of course, you will see here in the unsaved configurations, is that you can save this configuration and you can create your own preset. So whenever then save a preset and you want to re-render something, you always have the same render settings. But talking about render settings, there's actually more. If you click on settings, you can see there is anti-aliasing, especially if you have small fine lines and you would like to render, you know, shots for product visualization, architecture, whatever, and you would like to increase the anti-aliasing because the fine edges need a higher sample rate, this is where you do it. So when you click on it, you see that you get the anti-aliasing options. And you can clearly see here as well that you have two different kinds of samples. You have the spatial sample count and the temporal sample count. The temporal sample count, this is what you want to increase, what I increase. So that means, for example, if I put in 8 frames are going to be accumulated, and the samples have been taken from 8 different pictures to actually render one image. As higher you go, as higher the anti-aliasing samples or quality will be. So this is, I think, very, very important for you for the beginner tutorial, especially if you would like to render higher resolution stills. So as I showed you here, of course, in the output settings, you can go up here, choose then any other, you know, resolution settings. And as you can see, the quality of this image looks super nice and the render was done very quick. When you click on the unsaved configuration, and also when you open the sequence, first of all, you can also specify what camera you're using. We are using the Cine Camera Actor, which is specified here, okay? Also very important. The unsaved, under the unsaved configuration, we have more settings, and you can see that you have also so-called high resolution settings. So if the render goes like really nuclear, let's say you need to do something for print and you cannot handle it with one frame anymore and you want to use tiling, then this is the way how you can do it, okay? Then what is cool is you have render passes like, for example, here detailed lighting or lighting only, and I'll show you how you can apply those. So for example, let's say you only want to render the lighting only pass. Just click on it. And yet, as you can see in the settings, you see that if we scale this here, you see the deferred rendering lighting only was applied. And what does this do? So if you're here in the lighting, you can see there is detailed lighting and lighting only. This is almost like a GI render only, as you can see here from the viewport. But when you specify, hey, I would like to have I would just like to render a GI render, this is how you do it inside of your configuration render settings inside of the render queue. So click render local, and then I also specified to override existing ones. And as you can see, now you have 2 files rendered in the final. Let's make this here extra large icons. But you can see that additional to my rendered image, I have also now my GI render or lighting only pass. Very clean. Look at this. Depth of field. Everything looks very clean, very crisp. Also the blur from the camera, the depth of field, the blurriness is very, very nicely done. And you see with those samples in HD, it goes so quick and it looks super, super nice. Okay. So let's say, for example, you are happy with the render settings you have been choosing and you would like to save this as a preset. Then you can go in here and you can say, you know what, I call this Bernhard's 8 samples again, or something like that. And you say like save this. Make sure it's within the cinematics movie pipeline in the presets, and then I saved here one before. I just overwrite the same one here. And if you do so later on, you see it here below in your presets. You can just click on it, and then, so to speak, all the settings you have been saving as a preset will pop up or will be used. And is an easy way to actually, load render settings and then use it over and over again. Another super quick and easy way to render an image is to take actually a screenshot. So to do so, click here and select high resolution screenshot, check it. If you leave everything by default and you just click the camera icon here on the right bottom below, it says take a screenshot, click it. It started taking a screenshot and it saves it in that specific directory, and you can see the image was taken and boom, done. You can of course also increase here the quality, whatever you like and however you feel like, hey, this is the quality or the resolution I need. You can check then the image size, and you can see this is now with 3090 pixels in the width and 1236 in the height. All right, now let's talk about how to render an animation using the sequencer. So the first thing I want to do is, of course, I want to set some keys. I did this here already before. Select your Cine camera actor and then set 2 keys here to animate that camera. You can clearly see from frame 0 to 150, if I play it, that's the short and quick animation. The second thing is, because it's an animation, you also want to select your Cine camera actor and then specify some motion blur, because you have now a motion also coming from the camera. This really varies and depends on the shot, the camera, or the objects that are moving, but it's important that you actually check this when you are going to render an animation. The next thing is that I also select my camera I want to work with, and I switch also from the default viewport to my cinematic viewport. And in here I also specify what frames I would like to render. So I say I would like to render from 0 to 150, or my entire sequence here goes from frame 0 to 150. And then you see here under the sequence tab, you see this little icon here right next to the camera, and you click render this movie to a video. So click on it. When you do so, you see different image output formats. By default, you have also AVI containers and so on. I highly recommend to render an image sequence for this video tutorial. Here I'm just using a JPEG image sequence. I also select then my resolution. In this case, it's full HD. And compression quality I leave by 100. I specify also my output directory. In this particular case, is it the render output animation folder. And I also would like to override all existing renders I did before. So everything else I leave by default as it is. And let's see what's happening. So if I click now capture movie here, click save selected, that all the changes you applied are being active. You see now here the render process started immediately. You see the camera, boom, the capture was finished. And when you check now the folder where all the renders are, you can clearly see there are 150 frames rendered. Now, of course, I used in the film back a different ratio, and so you get those black bars, okay, but you could also change then inside of your film camera the film back and change this back to a full DSLR HD format, if you will. A cool feature I recommend, this is a free tool. This is the so-called DJV viewer. It's a free RAM player. And if you would like to see your animation, all you have to do is drag and drop one of the frames into the viewer, into the player, and you can see the animation in a live preview, what you have been just rendering out from the Unreal Engine sequencer. Well, I would say congratulations, because if you made it so far through all the chapters in my Unreal Engine for Beginners tutorial, I think you are ready to create your own first game. I'm curious what you really would like to do, and as I mentioned before, it really doesn't matter if you are going to use the Unreal Engine for a video game, if you use it for cinematics, for teasers and trailers, for product visualization, especially also for as a designer, if you're in aviation, in the automotive industry, if you're in the tech industry, in the entertainment industry. I mean, the options are kind of like infinitive. And as you can see here in this demo scene, what I created, it is all combined, because yes, we have cars, we have airplanes, you can use it for architecture visualization. So it's really up to you and to your industry. But for me, it was important to show you what is actually doable, what's feasible, and what's possible, and for what specific purpose can you use this powerful Unreal Engine for your own purpose. Of course, if you do need any help, if you have any other questions, no matter in what industry you're working, please feel free to contact me. I'm absolutely happy to help you, and I'm pretty sure we will find a way to work together for now and also in future. If you would like to receive automatically a notification when I'm going to publish my next video tutorial, please subscribe at my YouTube channel, click the bell button, and make sure that you select also for all notifications. And yeah, I would say that's about it. I hope that my beginner Unreal Engine tutorial was really helpful for you, and that it also motivates you to jump straight into it. And yes, I would love to see your work. I would love to also see you on my channels, on my different channels, to see what you're working on, and let's talk and let's team up and let's work together and let's have fun. So that being said, all the best and happy creating and pixeling. Take care. Bye bye.